All right, let's try this again. Happy Friday to you. Don't see that I'm live yet, so hang in there with me. There's always a little bit of delay. There it goes. Okay. All right. We're going to try this again. Sorry about that. If you joined me on the first one, have some little technical difficulties. So I'm really excited. Happy Friday to you. I'm pretty stoked about going to be at Rapid for a few days. Going to be on a panel on Wednesday, I believe, around noon. So that should be fun around healthcare. And then I'm going to be bringing something that's going to be a lot of fun, a new arm that I want to show you here in just a little bit. But I also am super excited about nearly the 100th episode of the Prosthetics and Orthotics podcast going live. So if you have not started listening to that podcast, I think it's a wealth of information. I know for me personally, I have learned a lot from that podcast. Let's see. I think let's just dive right into the arm here. So we're going to go here. We'll get my head out of the way. And if you have any questions, don't hesitate to leave them in the comments. I think I get to see them right in front of me. So the other cool thing is I have a new toy. So I'm actually looking right at my screen, which is behind my camera. So it looks like I'm looking right into the camera, which is really neat. And I'm always moving around. I've got all kinds of monitors over here. I've got a light source over here. So there's always things going on. But I wanted to share with you this arm. I'm really excited about it. We've got lattice. Let's see if there we go. So lattice structure. It's going to be I'm going to take the liner off for the time being. It's going to have a motion control wrist. So we're adding the motion control wrist. I wanted to make it super lightweight, but so you could see all the electronics on the inside. So I'm really excited about that part too. And then you can see that I've given proximal and distal or palmar and volar areas that we can load on the real small flexible inner liner. And then you may wonder, what are these little round holes for? Well, instead of using rivets, we can actually connect it via these little tabs. And so those little tabs mean there's no metal. It's just super easy in and out. So I'm really excited about that part. So you can see that fitting together. So I always say nowadays, little Brenties, a little Brent topology, and yeah. So this is cool. So the frame, motion control wrist, all latticed. The psionic button charger port is going to be right there, and then you've got top and bottom, and then all these edges, just real nice there. So now let's go to the liner. What's special about the liner? Well, you saw the lugs for the liner. So there's the lugs. This is going to be BASF TPU. And take a look at this. So this is over the condyle. This patient said that they were feeling a little bit like it felt good, but over a period of time, they felt like it could get too tight. So I went ahead and created a little bit of an offset here. And then you can see that we have a reasonably good lattice structure in there that will be able to be compressed. So one of the neat things about doing the flexible inners this way with an inner membrane in a lattice structure, significantly cuts down on the cost. It's a lot less than the material cost. And then once you vapor polish this, it really is amazing. So, and then here are the areas for the electrodes to pop in, silicone electrodes. So I'm really excited about this. I mean, you may be concerned about this kind of digitization, but just remember, we're going to be, or pixelation, not digitization, we're going to be doing a vapor polish on this, and so none of that will even show up, and probably the resolution would be so great that it's not going to show up anyway in the print itself. So I'm really excited about showing off this arm. It's going to be super lightweight, and it's going to be in a location that you probably wouldn't expect. So you're going to have to come to Rapid and find out what we're up to. Oh, one last little piece in this frame. So behind the area for the electrodes, I just have a little small area that indents there. So you've got an area for those electrodes to push. You got areas for the wires to go down. Now, you notice that everything's going to be open. So, when you look inside of this, it's going to be up to whoever's getting this to make sure that the wires are running straight. It doesn't look like a bee's nest, that the batteries are pushed down or in a good spot. So that's one of the downsides of having an open lattice structure, is that is the case. So that is that. So if you've got any questions, let me know. So you may be wondering, well, what program am I using? Well, this is Oqton Freeform. And Oqton Freeform, you use a haptic device, which means that you can actually, so when I'm swinging this around, I can actually feel the socket under my hand. So really neat. And I think it's just a great way to go. You're able to not only manipulate the whole mesh inside, but then you can actually export your final file. So whether it's a 3MF file, OBJ, you can also add color, which is a lot of fun as well if you print on the Multijet Fusion 580 color machine. You get some really great colors going there. So I'm going to go back to my regular camera here, and I'm going to make myself a little bit bigger. And I want to show you another project that I'm working on, which is a lot of fun. So, hey, John. Sensors on the device. So there's actually 2 electrode sensors that, and I'll show you actually where they are. Let's go back to this. So there's 2 sensors, and they're actually spread apart. So they look at the myoelectric current between the 2 when the patient flexes their muscles. So one is for flexion extension, one is on the other. Now, that is for the movement of the hand. Now, you mentioned sensors, which is a very interesting choice of term. So thank you for that. One of the interesting things about psionic is that there is a vibration sensor that goes in the fingertips. So it actually allows for people to feel when they pick something up. And they're also looking at doing some intra-nerve things with osseointegration, so you can actually feel hot, cold, and individually use those fingers. So there's a lot of really cool things coming down the pike from psionic, and this is a more standard prosthesis, but there's going to be features in here that allow them to do some other things that they have coming down the pike that they weren't able to do before. And because of this wide open way that we're able to make it with the 3D printing, they're able to get more stuff in that arm. But the key there is to make sure that you keep it nice and lightweight. So great question, John. Thanks for hopping on there. So the other cool thing that we have going on is a lot of people have jumped on the bandwagon for Bamboo Lab printing, and it is amazing. Oh yeah, you got it, John. Thanks for calling us, or is it calling in the show? I don't know. But anyway, the other cool thing is, um, with the Bamboo Lab, you're limited in your print volume, so you really only have 250 millimeters. So what does that mean? Most sockets are not going to fit on that unless you cut them in half. And so we're working through some algorithms which are done, and I wanted to show you some of this. And it's two different colors, but you can use different materials, and then you can figure out how you're going to clinically manage it. But what you do is your input is actually going to be just the mesh itself with trim lines. And then I made it two different colors so you could see this. But you have the proximal section and a distal section. And the cool thing is if you do all this in alignment, you're only talking about 20 to 30 seconds of work, computational work. And then it's up to you to use the adhesive of your choice, heat, whatever it is in your clinical professional opinion, to put these two together. But I can tell you that it's a great way to go. And for a printer, that printer that I'm talking about is $400 and some dollars. It's a great way to get involved in 3D printing for a low cost. I think it's really great. If you want to know more, please reach out. I think this is really the future. And one of the neat things is Bamboo is international, right? So the people have printers all over the world. And my vision is, hey, if we can help people design, we can actually do centralized design, decentralized production, and specify via some different files, specifically 3MF files. If you're into that, and if you listen to our last podcast, you know why I'm so excited about that. But the reality is, we can bake in even the specific machine and material into the 3MF file to be sliced in the way that we expect it to be sliced. And at that point, it starts becoming a recipe that's consistent for patients worldwide. So I'm excited about that. I'm really excited about that. I hope you can sense that. So that is really all I've got today. I am some of the latest stuff that I've been working on is just looking into some of the historical patents, specifically around adjustability. I think that is neat, and I think it's super important for vendors that are selling these type of things to go ahead and know that there's a lot of prior art there, and more than likely, especially around adjustability, even like air bladders and things of that nature, it's already been done. In fact, a lot of that stuff is late 1800s and early 1900s. So there's really nothing new under the sun there. So I may do a breakdown on the adjustable socket stuff, or maybe even some on timeline. And then, I always enjoy doing the breakdown of the annual reports of some of these big companies. And, maybe we'll see one of those sometime soon. So anyway, in the meantime, have a great weekend. Thanks for jumping on.